Have you ever wondered if you can know exactly where a soccer ball is and exactly how fast it's moving at the exact same time? In the world of the ultra-small, the answer is a mind-bending no. Let's explore why. When a soccer ball sits on the pitch, it looks perfectly still. We feel like we have total information about it. But at the subatomic level, measurement isn't just difficult. It's fundamentally restricted by nature itself. In our everyday life, we use classical physics. We assume objects have definite properties at all times. We track soccer balls with cameras and sensors, calculating their trajectory with high precision based on classical laws. Classical physics suggests that if you have enough data, the universe is like a clockwork machine, entirely predictable. But step into the quantum realm, and that clockwork disappears into a fog of probability. At the smallest scales, particles like electrons behave less like little billiard balls and more like spread-out waves. This leads us to Werner Heisenberg's uncertainty principle, the fundamental limit of precision. The more precisely you pin down a particle's position, the less you know about its velocity. They are inversely linked. To see something, we usually bounce light off it. But at the quantum level, that light carries enough energy to knock the particle off course. By the time you see the particle, you've already changed its momentum. The act of observation changes reality. This isn't just bad technology. It's a trade-off encoded into the geometry of the universe. So why don't we notice this with a soccer ball? A soccer ball is made of trillions of atoms. The tiny uncertainties of each cancel each other out on the macro scale. For objects this large, the quantum blur is so infinitesimal that for all practical purposes, it doesn't exist. The uncertainty principle is the bridge between the fuzzy quantum world and our predictable macroscopic reality. Ultimately, the universe is probabilistic. Randomness is built into the very foundation of existence. Next time you kick a ball, remember, even if it looks certain, it's dancing on a foundation of quantum mystery.